Hey guys, a little more casual today in my t-shirt. Just been working around the house while I'm doing stuff online. Excellent job getting a hold of me and sending me emails, asking about questions and asking about some of the problems that the figures did not show up on the attachments that I put on there. Keep that up, folks. That is awesome. It helps me get better with this stuff, and I'm learning how to attach and send things and get it a little bit better. Now, we're going to do day two. Day two of this is going to be page 2 of the test. Hopefully the pictures and things and projects show up. If not, just keep asking. I'll forward it to you in the emails, and it's really not that big of a deal, not that tough. First thing that we're going to talk about, number 1, is variables on both sides of the equal sign. So I'm talking about a problem like 5 times the quantity of x minus 9 is equal to 2x plus 15. See if you wrote it right. I'll give you a few seconds. You can pause it and then come to it. Pause is over. All right. 5 times the quantity of x minus 9 is equal to 2x plus 15. First thing you've got to do, get rid of the parentheses. Okay? When you get rid of the parentheses, the distribution, 5 times x is 5x, and 5 times 9, or negative 9, is negative 45. Rewrite the whole problem. So now you've just got basically a two-step equation where you're going to put the x's all on one side and the constants on the other. In this case, I'm probably going to move the 2 over with the 5, simply because it's the smaller number and it's going to work out a little bit nicer. So if I move the 2 over with the 5, that means I've got to move the 45 over with the 15. Okay, just to balance it out. I'll show you in a few seconds while I write it out. If I move the 2, I subtract the 2x from both sides, and it's left me with 3x. But if I subtract the 2, that means I've got to add the negative 45, add a 45 to balance this out. And 45 plus 15 is 60. Okay? So this is what it looks like. Okay? This is what this problem looks like with this. So you've got just a one-stepper now. Easy one-step problem. 3x is equal to 60. Just divide by 3, and x should equal 20. That's variables on both sides, actually with a little bit of a parenthesis with the distribution problem thrown in there with it. That's the extent of variables on both sides. It's just putting the variables on one side, the constants or the numbers on the other, isolating the variable. Remember that term. Isolate the variable. Get the variable by itself. We're trying to get the variables on one side, numbers on the other. Now, part 2. Part 2 on this is proportional equations with a binomial in it. Now, a binomial just means like x plus 7, something of that nature. So if I had x plus 2 over 6 is equal to 5 over 3. Okay? This is what it should look like. X plus 2 over 6 is equal to 5 over 3. This is exactly like the other proportional problem, the fraction problem that we did before. Cross multiply. Cross multiply, and it's just going to turn into a two-step equation. Okay? If you cross multiply the 3 times the x plus 2, it turns into 3x plus 6. Okay? Cross multiply the 3 times the x is 3x. 3 times the 2 is 6. Now, cross multiply these two, and you'll multiply the 6 times the 5, and it should make 30. Okay, 6 times 5, and it equals 30. Because it's a proportion, you put an equal sign between them. Equal sign goes between them, and it's 30. Two-step equation. Okay, subtract the 6, divide by 3. That's all you do. Most of you, I'm hoping, you get to this line right here, easy, nothing. That's where it's easy. Two-step equations, you can do them in your sleep, okay? If that's your goal, get it to the two-step, the game's over, okay? So I'll show you the rest of it really quickly. Subtract the 6 from both sides. 3x is equal to 24. Divide by 3, and x should equal 8 in this problem. Sloppy, done quick, but you should know it. It should almost be mental math for you, okay? Next part that we're going to do, a fraction equation, okay? This is one that I'm going to show you my way. Some of you may want to turn it into or work with it as fractions. I hate fractions. No. Okay, let's say you've got this problem. 3x minus 1/6 is equal to 2/3 x plus 5 over 2. Okay? Fraction, 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 fraction. Yippity skippity. Okay? That's what this one is. Ugly. Ugly problem. If we're going to move the variables to one side, you're going to have to take 3x minus 2/3 x. That makes 2 and 1/3. No, I don't want to work with mixed numerals. Yuck. I don't want to work with fractions. So, see if you remember. What do? Pause it, say it out loud, whatever. You're right. You multiply everything by the common denominators of the fractions. Look at all the denominators. You've got a 2, a 3, and a 6 for the denominators. A 2, a 3, and a 6. What is the common denominator? The lowest common denominator. Any denominator would work that's common, but the lowest common denominator is going to create the least work. What is the lowest common denominator for those three fractions? You're right. It's 6. Now, remember, that means you multiply each part by a 6. Each one of these pieces by a 6. Why am I doing that? It's so I cancel out the denominators. I won't have fractions anymore. I'll just have whole numbers. So let's see what that looks like. Every part of this gets multiplied by a 6. Every piece of it. Okay? Watch what happens. Okay? Easiest one, 6 times 3. 6 times 3 is 18. No brainer. 6 times 3, 18x. Done there. Okay? 18x. This one, 6 goes into 6. How many times? 6 goes into 6 one time. What's 1 times 1? 1. Okay? 1 times 1 is 1. Oops. And the 3. How many times does 3 go into 6? That goes in 2 times. Okay? Reduces that to 2. And 2 times 2x is just a plain old 4x. Okay? The 3 goes into the 6 2 times. 2 times 2x is 4x. Now the last one, how many times does 2 go into 6? Goes in 3 times, right? 3 times, simple enough. Okay? 3 times 5 is 15. So, this whole monster turns into a two-step equation with variables on both sides. Okay? Still not out of the woods. Variables on both sides. You've got to isolate the variables. Get the variables on one side. Get the constants, the numbers on the other. In this case, I'm probably going to be moving the 4x over to here. Just because it's smaller. Just because it's smaller. That's the only reason. So if I move the 4x over to here, I subtract it. I move the negative 1 over there, and I add it. Okay? It should look like this. Minus 4x from both sides makes 14x. Subtract the 4x from both. Cancels out here. 18 minus 4x is there. If I move the 4x over to here, it means I've got to move the 1 over to there. So I add 1 to both sides, and it should be 14x is equal to 16. Now, do not worry. It doesn't work out nice and neat. Don't freak out if it doesn't work out nice and neat. It turns into a fraction. Oh, no. Divide both sides by 14. It turns into 16 over 14. Just reduce it to lowest terms. Don't turn it into a mixed numeral. Devil's work. Just leave it as 8/7. Well, 8/7. 16 over 14, they both divisible by 2. Should turn into 8/7. You're done. That's it. Walk away. All right? Next part. Multi-step ugly. Multi-step equations. Really, it's not that much different than the equations where you had the variables on both sides. Okay? It just adds like some distribution in it and some combining like terms after you've done the distribution. It's a lot to write. 3x plus 10 minus 2x is equal to 5 times the quantity of negative 7 minus x plus 1. Okay? So if you pause it, try to write it out, this is what it should look like. 3x plus 10 minus 2x is equal to 5 times the quantity of negative 7 minus x plus 1. Okay? Get rid of the parentheses on this side by distributing 5 throughout it. Combine the like terms, the x's over here. It's going to make it look a little bit nicer, okay, a little bit less hideous. When you combine the like terms, a negative 2x and a 3x on that side, it should just make a 1x, or just x. Yeeks, tough to write backwards, upside down. X plus 10. Distribute the 5 throughout the parentheses, it should turn into a negative 35 minus 5x, and then bring down the plus 1. See what I did? I distributed the 5, turns into this. I can still add these two parts right here. Well, not really add, it'd be subtract, because one's positive, one's negative. So it's negative 35 and a positive 1, it should make negative 34. So let's rewrite the sucker. X plus 10 is equal to negative 5x minus 34. Okay? Now I've got to bring the x's to one side, the numbers to the other. Being that this is a negative 5x, let's bring it over to here, make it a positive. Okay? And don't forget, if there's nothing there, there's a 1 out in front. Okay? So let's bring the 5x to the other side. Since it's negative, I'm going to add 5x to both sides. That cancels. Add 5x to both sides. Then the negative or the positive 10, I'm going to subtract 10 from both sides. And this is what it should look like right here. Okay? You brought the 5 over to here. 5x and 1x makes 6x. The 10 goes over to here. A negative 34 and a negative 10 make negative 44. This doesn't work out nice either. Okay? Big deal. Big deal. Okay? That's 6x is equal to negative 44. Alrighty? Now, next step is just dividing by 6. And 44 divided by 6, it's going to reduce to what, 22 thirds? I don't care. 22 thirds it is, okay? The problem on your test, not nearly as tough as this. Not nearly as tough. So all you need to do is practice the one that's on the page, and it's going to be fine. Alrighty? Now, last two things are going to be really quick. I only have about 4 minutes left to get all this out to you. Okay? The last two things, finding a mistake in a problem. I'm going to tell you right now, when you start working out page 2 and it's the second to last problem, they give you 2 ways that people worked it out. Don't start piecing through both of them and working it out with what they did. Do the problem first. Then take your way of doing it and compare it to the 2 ways and find where they made the mistake. Be able to articulate, be able to write it down where they made the mistake, what they did wrong. Did they forget to distribute? Did they multiply by a negative and forget that it was negative? Did they add when they should have subtracted? Whatever it is, you're going to find a mistake. If you don't find a mistake, then you probably did the problem wrong. So just check it and make sure. That's all that you're doing with that one. It's a level 3 and it's really simple, really simple. Now the last part of it is the easiest level 3 that you will ever get. It is the one solution, no solutions, or infinite or many solutions, all solutions, okay? This one's the easiest problem in the world. One solution is what we've been doing all this time with solving an equation. We find out the solution. So 90% of the equations that we work with are one solution problems for what we're doing right now. X equals 7, one solution. Everything that we've done so far in this chapter, one solution. But no solutions. A no solution problem looks something like this. 5x plus 7 is equal to 5x minus 3. Variables on both sides, but something that you're going to realize really quick. Wait a sec. 5x and 5x on both sides, they're the same thing. So if I move the 5x to the other side and it turns negative, won't the 5x's cancel each other out? Let's see. I bring the 5x to the other side. Doesn't matter which one I bring it to. Subtract 5x. Subtract 5x. They cancel out. The x's are gone. You have nothing. You're left with just the 7 on the one side and the negative 3 on the other. The 7 on the one side, the negative 3 on the other. Is 7 equal to negative 3? No. That's why this one is a no solution problem. No solution. Okay? No solution at all, because it doesn't work. And it will never work because the variables cancel each other out. Now, if I change this problem ever so slightly and make the plus 7 into a negative 3, just change that part of the problem. I change the 7 into a minus 3. Then we've got the exact same problem on both sides. 5x minus 3 is equal to 5x minus 3. The 5x's cancel out. I'm left with negative 3 equals negative 3. Isn't that a true statement? Isn't negative 3 equal to negative 3? That means any number that you put into this problem is going to be a solution. It's going to work. It can't be wrong. So that's why this one is, I refer to it as infinite solutions. The paper or the problem says all numbers. Okay? All numbers. I don't like that. I say infinite. Infinite solution means that there's an unlimited solution that keeps going. There's a ton of solutions. So one solution, 90% of the problems that we do, you get an answer. No solution, that means the variables usually wipe out and you're left with two numbers that are not the same. Or it equals 0, like 7 equals 0. Still not right, doesn't work, okay? And then infinite solutions is when it's the exact same thing on both sides. Try the second page, okay? All of the second page, numbers 5, 6, 7, 8, 9, and 10, I think, 5 through 10. Just the second page, these types of problems, that's your homework for tonight. Good luck, be safe, I'll see you soon.